Hello and welcome. This is not a problem solving session. In fact, I'm going to provide you a perspective. In fact, I received this problem in an email when I was a break. I was on a break, and the problem simply read like this: a thin-walled half tube, half cylinder of mass m and radius 2r can roll without slipping on a horizontal flat surface. A cylinder of mass 2m and radius r with a homogeneous mass distribution can also roll without slipping inside it. At the moment t equals 0, the half tube is at rest and the cylinder's axis is moving with a small horizontal velocity v0. Let's give the angular deflection of the half tube or pipe as a function of time. This is basically translation from Hungarian language. So, for the very first time I saw the problem, many thoughts came into my mind, and I couldn't reach to a final proposition, any proposition at all. Then I saw this is an Olympiad problem and read the name Rudolf Ortvay or something like that. I knew I don't have to solve it because this competition doesn't require a solution or require a solution or the solution. Rather, it asks for a perspective you can provide. So I decided to provide my perspective on it. And here is my perspective. You can have yours, and I request you all to share yours, your perspectives. So the problem begins with a velocity given to the center of this cylinder, a small velocity v0, this velocity, and no angular velocity. That means it's going to sleep first and roll after. But when the rolling will begin, so to find the condition, you need to have the friction coefficient between these two surfaces, which is not provided, of course, not given, and there is nothing you can do to find it. So I thought that the initial speed is just small enough. That means I started thinking that if in a very short time before the rolling begins, we consider the surface under the cylinder as a horizontal, very rough plane, I thought, and this short-term frictional force shock changes the mechanical energy and momentum of the ball, but does not change the rotation of the ball relative to the point of contact with the ball. That means I thought both the half cylinder and solid cylinder starts rolling together in a very short interval of time. So that the configuration of motion doesn't change at all, and I have an instantaneous center of rotation right at the point of contact at the surface below, here, somewhere here, and their angular velocities may be different because they started rolling together. So, and here is the instantaneous center. So I thought if its angular velocity is omega 1 and its angular velocity is omega 2, just after the rolling begins, the initial condition is this, and there is no rolling initially. And after the rolling begins, after a very short interval of time, and they start rolling together, its velocity will be simply omega 1r, and its velocity will be omega 2 multiplied by 2r. 2r is its radius, and they must be same. And that means what I'm trying to tell you, that in such condition you can write omega 2 multiplied by 2r equals omega 1 multiplied by r. Omega 1 is the angular velocity of this cylinder, and omega 2 of this is the angular velocity of this half cylinder, and you can get here whatever you want to tell. Omega 2 is equal to omega 1 by 2. I got this. And then I started writing. You can write nothing except the conservation of angular momentum about an axis passing through the point of contact of a whole system. Here, let's name it point P. And you will get your result. Only you have to think that you can only think that its center of mass, before applying the parallel axis theorem, you have to take care that its center of mass is not here. It's somewhere at a distance 2r by pi, 2r not 2r, 2 multiplied by 2r by pi distance here. And so you will write, and here is the relation between angular velocities, and you will get omega 2 as a constant, and then you can write the angular displacement simply as theta equals omega 2t, because at t equals 0, omega 2 was equal to 0. And this is my perspective for now. If I think something else, I will share with you, or you can share your perspective with me as well. Thank you very much for watching.